So this is my development F6100 CMC. We're going to talk about upgrading the stepper drives today and testing each motor individually. So I want to explain this system. So I have removed the computer from the lower part of the cabinet and the power supply and the motion controller. And I have put the motion controller in this PC down here, which is a standalone unit, so I could get a newer PC. Yes, this PC still runs Windows 98. Okay, so the cables come up from the back of the machine into the cabinet and then transition into these ribbon cables, which run up to this interconnection board. Alright, there's a lot of lights on this board that tell you a lot of status lights. This section right here, I'll turn this light on. This section right here is the input section. There are 8 inputs. They are numbered 0 to 7. Alright, we'll talk about these individually. This section here is the outputs. Again, 0 through 7. Below the inputs is a section for drive status lights. There are 3 motors on this machine, or 3 axes. The C axis, C for cutting head. The Y axis, this is making the cutting head go up and down the arm. And the X axis, which makes the arm go left and right on the table. In the middle, there are the limits. There is X and Y forward and X and Y reverse limits. So positive for forward, negative for reverse. There's the home lights. One for each axis, so the machine can find its home position before it starts cutting. And then there are the power status lights. The 5-volt DC light lights up when your computer is turned on and the motion controller has power. The 24-volt DC light does not come on until you turn the power switch on the machine, and the safe light, 24-volt safe, does not come on until you press the enable button. Alright. Inputs are connected to the board up here. You can see we only really have 2 inputs. Outputs here. There are technically 3 outputs, but we only use 2. The power supply from the back of the machine connects here. So those are your home and limit switch wires, and you'll see that like this cable goes over to these connections on the back side of the machine. And now we have our drive connections. So each motor has a stepper drive, C for cutting head, Y for up and down, X for left and right. Now, if I can show this, these cables run over here and they connect to the back side of each stepper drive. This is the C axis at the top, this is the Y axis in the middle, and this is the X axis at the bottom. There is the difference between them. The drives are physically the same drive, but if you look, there's a certain set of dip switch settings for X and Y. They are the same, but the C axis has its own setting because it's a smaller motor. Okay, there is a status indicator light for each drive. The motors are connected to this connector on the drive. So the computer is connected back here telling the drive what to do. The drive then tells the motor what to do from this end. Now when we do an upgrade and we change these drives from the old original drive to the new drive, it's very important that you keep the black wire and the red wire that are next to each other paired together, and the white wire and the black wire paired together. Now on an original OEM drive, this red wire is in this position and the black wire is in this position. But on these drives, because of the way they're manufactured, we have to switch these two wires. So that's in the instructions that come with the drive. These stay in the same position. Now there are some changes to the wiring in the back. We remove a white wire that's no longer back here, and we change an a black wire. So let me stop, and I'm going to unplug this. To unplug this, I pull the connection to the center of the box. Alright, and then I'm going to show you how to take the cover off and reposition the wires. Alright, we'll be back in a minute. Okay, so I've unplugged this connector here. This happens to be the X, obviously. So if I lift up on the lip of this white cover, then I can basically rotate this cover back off of the top of the connection. That was my air compressor kicking on. Alright, so in the standard wire, there is a black and a white wire here in these locations. The black wire needs to be moved down to this location. Now these little gold, these are called punch down connections. So you can see here the wire's not stripped. The wire is just pushed down into that gold connection, and the connection cuts the insulation. So to take a wire out, you pull the wire out of the connection, and to put one in, you push it down in the connection, and that's all you need to do. And then here we've cut the white wire off because we're not using it. And then to put the cover back on, we hook it on the back here and snap it around, and now the cover's back on and we can plug it back in. Okay. Alright, so now every Fletcher 6100 has an emergency stop button, an enable button, and a power button. So if I turn the power switch on, then you'll see some lights turned on back here. The 24-volt light turned on. The safe light did not turn on because it's not enabled yet. The limit switches are all lit up. If you're on a limit switch, if you hit a limit switch, these will turn off. As long as these are on, it's okay for the machine to go. Home switch lights are not on at this point. But if I move the arm closer to the left end, I can get that home switch to come on. If I push the cutting head down, oh, there the cutting head home switch, the Y-axis home switch light came on. And if I turn the cutting head, now I've got the cutting head home switch on. So that's how you detect if your home switches are working. You can rotate the cutting head, move the arm for all of that to work. Alright. At this point, no lights are on the drives because I have not pushed the enable button. When I push the enable button, well, first we have to release the emergency stop button, right? So I gotta twist the emergency stop button and it pops out. And when that happened, input 1 light came on. When I press the enable button in, you're gonna see input 0. When I press the enable button in, you're gonna see input 1 come on. and then go out. So when I press it in, it comes on. When I let go of it, it comes out and goes off. And then that has enabled a relay on the power supply on the back of the machine. So now the 24-volt safe light is on, and we have green flashing lights on all of our drives. Okay. And in my case, I have a light on the enable. Your light bulb may be burnt out, and that light bulb is in this part of this mechanism, and so this can be taken apart and the light bulb can be changed and replaced. Alright, so now let's talk about how to run the machine and test each motor with a special piece of software called the motion console. Oh, turn the light off. Okay, so on my machine I have the Fletcher design software that you're used to using, but I also have an icon for the motion console. This allows me to talk to the motion controller without designing a mat. Alright, I'm going to show you how to find that because you probably don't have that on your machine. So we're going to go to the start button. We're going to right click on the start button, and we're going to pick left click explore, and that's going to bring up the Windows Explorer window. Okay, so I'm going to scroll up and I'm going to look for desktop, my computer, C:. This may say Fletcher on yours, Fletcher C. And I'm going to look for this MEI folder. And I'm going to click on the plus sign in front of MEI, and that's going to expose the folder inside, 25. I'm going to click on the plus sign in front of that. That's going to expose the folders in there. I'm going to look for the MoCon folder, and there's no plus sign here, so when I click on the folder, it's going to open this side up, and you can see the MoCon 31 program right there. If I right click and hold on this, hold, and then drag it over off of the window, you see that little arrow that's dragging along with it? That's the shortcut arrow. So if I let go, it's going to say, do you want to create a shortcut here? And I'll say yes, click that. Now I have a shortcut that I can use to run the program at any time. I don't have to go find it. To get rid of the shortcut, you right click on it and pick delete, and then it asks you to confirm the action. Okay, so that's how you find the MoCon 31. I'm going to close this window. Alright, so I'm going to double click on this icon to start the program. Alright, so this is the motion console. The window inside of it is called the hardware summary. The first thing that's most important to see is this yellow smiley face. If this is a red frowny face, then the motion controller has a serious issue. It's probably bad. And so this is important to have this. This is the address of the motion controller. It's a 3-axis motion controller, X, Y, and Z axes. These are the 3 axes over here in the axis list. This is the X, the Y, and the C axis. If I click on the C axis, double click, it will open up this window. In this window, it's very important that these numbers are not changing. If these numbers are changing, even though you might have a smiley face over here on the this is going to indicate that there's a bad problem. If these numbers are changing, there's a bad problem with the motion controller. All right. Occasionally, you're going to see a fault on here, and to get rid of it, you just click clear fault, and that'll turn to no event. We cannot run the motors if there's a fault in here. Over here, do not change these numbers. Don't worry about them. We're going to worry about these two numbers, the velocity and the acceleration, and we're going to use relative mode to run the motor. So let's turn on relative mode. All right. This is how many steps it's going to move from wherever the cutting head is. All right. Or where the motor is, the arm is sitting, whatever. Now, here's some indicators down here that are telling you status. So just like the drive lights over here, and these lights tell us things. So like right now we've got home sensor low, and over here we've got a light on. So whenever that light is on, this should say low. Now if I turn the cutting head and turn this light off, okay, now the status on the screen is changed to high. I'll turn it back. There's low, and there's high. In order to run the motor, we have to first enable the drive. So if we click this box, now when we did that, it turned this light on, the enable light, for the C axis. So I'm going to click it off and click it back on. Okay. And once we've got that, now these buttons will work. This will run the motor forward, or in the case of the C axis, it's going to turn the cutting head counterclockwise, because positive angles in math are counterclockwise. So when I click this, you're going to hear the machine run. And you're going to see that these numbers changed and became 8,000, because that's where I told it to go to. And if I hit this, it's going to go back. All right. So now I'm going to show you the picture of the motor running. So now we're going to look at the cutting head, and I'm going to click the forward button, and then I'm going to click the backward button. Okay. Your machine may make different sounds now that you have new drives in them, because they have different algorithms for controlling the motors. If I want to make the cutting head go faster, I can change this number. Maybe we'll double the speed, and we'll see what happens when we do that. So now let's watch the cutting head. See, it went a little faster. All right. Now let's change the acceleration. Let's double that. It's called 60,000. Now let's watch the cutting head. Here we go. And you can see the sound changes with the speed and the acceleration. So this is proof that the drive and the motion controller and the motor and all of the wiring are all good, and the machine can run just for the cutting head. All right, so now if we're going to stop the cutting head, we're going to disable it, and then we're going to close this window, and we're going to try the next motor. So if we go to the y-axis, axis 1, double click on it, we've got the same thing. We've got settings over here we're not going to change. We've got indicators here. Now in this case we have over travels or limit switches and a home sensor. All right, now this one, again, we need to check and make sure there's no numbers running away here. Just running, we're not doing anything. So they're not. Now we do have, in this case, a stop event. So this is because we're sitting on the home switch. We can't run this with the home switch on. So I'm going to move the cutting head up a little bit manually. And so now you can see I'm not on the home switch anymore. And the home switch in here is off. And so now I'm going to tell it to clear the fault. And now we have no event, so we're good to go. So now I can click relative mode. And I've got my velocities and accelerations in there. And so this is going to make the arm go up. And this is going to make the arm go down. So if I click this button, it went up 8,000 and then went down 8,000. Now you didn't hear the machine run because I forgot to click the enable button. So let's click the enable button and let's turn the enable light on right here for the Y axis. And let's try that again. So now the head moved up the arm and down the arm. And we'll watch the head. Up and down. Okay, that motor sounds totally different because it's a different kind of motor, bigger motor. So again, we could mess with the speeds and the accelerations and play with things like that, but we're just trying to make sure that everything works. So we're done with that because it works, so we're going to click disable. All right. And so now we're done with testing the Y-axis, so we're going to close this window. And now we're going to click on this, and we're going to double click, and we're going to look at that one. Oh, we don't have any numbers running away here, but we got a stop event because we're sitting on the home switch right here. So I'm going to move the arm over until I'm off the home switch. I'm going to clear the fault. All right. I'm going to check relative mode. I'm going to make sure I enable the amplifier. So I've got a light on, enabled. And so now I'm going to press this button, and this is going to make the arm move to the right on the machine. And this is going to make it move to the left. And so if I watch the cutting head, move to the right, move to the left. So that's all working. So now we'll disable the drive and we'll close this window. Now there's one more thing to look at, and that's user IO. And in the user IO, that's all of our inputs and outputs. This is the inputs. We don't use port 0. We don't use these, but these correspond to these lights. This section says inputs, but we're going to change it to outputs because that's what we're using them for. Okay, and you heard that. And I'm going to turn all the outputs off right now. Okay, so I have no output lights on right now. Okay, so with the outputs, we've got we call this PC0, PC1, and PC2. So let's see what PC2 does, or PC1 does. That turns the clamps on. So if I hit this, if I hit this, I get output 1 light turning on. And the clamps are down. So if I hit this, now the clamps are up and the light is off. Okay, so let's turn the clamps on. Now let's do the cutting head. Okay, so now I have 2 lights on because I have the clamps on and I have the cutting head on. And the cutting head is down against the table. Okay, if I turn this off, now the cutting head is up. If I turn this off, now the clamps are up, so that I can see all of those things are working. Inputs, right now we have the input 0 is on, input 0 right there, input 0, that's on. So if I push the emergency stop button in, now input 0 is not on anymore, and it's not on the screen anymore. So if I release the emergency stop, see that changed, push it in, release it. All right, now input 1 is the enable button, so that's our enable button. So when I press the enable button in, you will see that change state, and then when I let go of the emergency button or the enable button, it will go back, but it leaves the power to the machine on, but that light at the same time goes on when I press it in and off when I let it go. So that's how we know the inputs are working. Now additionally in here, we can actually tell the motion controller to reset. Doing this basically wipes the memory in the motion controller, and then we have to upload or download a file that gives the motion controller instructions to become a Fletcher 6100 instead of maybe a factory conveyor belt or a robot or something like that. So this you probably shouldn't do this unless you're asking for help or qualified, pretty confident in yourself. So this will actually, when you click this, that actually reset the motion controller. Clicking this button resets the motion controller. Then we have to click on download from file, and we have to find the Fletcher 6100 program, which is under the C, and then have to go to program files, and then Fletcher 6100. And then we have to find this particular file, and we click that file. Then that says, hey, we're gonna replace the firmware on the controller, and okay. So now that has reconfigured the motion controller into a Fletcher 6100 again. We only want to use this if we can't reset it with a couple other ways first. Alright, so now to exit this program, we click close window, we close the program up here in the corner, and now we're done. We press the emergency stop button on the machine, and we turn the machine off, and we're done. Okay, and then if I click start and shut down, you will see that light went off when the power to the PC went off. So that's how you test your Fletcher 6100 and make sure everything's working correctly.